This is the podcast on fossil fuels. I'd like you to use this to supplement your data tables that you're filling out to make sure that you haven't missed anything and maybe add in a few things that weren't in your textbook. First, we're going to go just a little bit over some background information that you don't need to necessarily write down, but I think is interesting information to kind of set the stage for the fossil fuels information. Just wanted to point out to you that, obviously the amount of energy that we're using as a society now is greater than any amount we've ever used as a society. You can see down at the bottom, we are considered part of the modern industrial age, and we use 766,000 kilojoules of energy, whereas if you keep going back in time, the energy amounts go down. And not only is the energy amounts going down, but you can see the rate of increase of energy use has been speeding up. So we're using more energy and we're using it more quickly. Some general background on fossil fuels. You do want to write this down as some notes for yourself. First, the difference between a renewable and a non-renewable resource. A renewable resource is a type that can be produced at the same rate that it is used. So we can use this resource and at the same time replenish it. I just want to make sure you realize that fossil fuels are not renewable resources. I'm just going to abbreviate here, not fossil fuels. Okay. The type of resource that our fossil fuels are is a non-renewable resource. These are resources that are used at a faster rate than can be produced. Now you probably know fossil fuels like oil, natural gas, and coal are all made deep under the ground over millions and millions of years from the decomposition of ancient organisms. So we're talking about things that lived millions and millions of years ago. If we had millions and millions more years before we needed more oil and natural gas and coal, we'd be fine. It would be a renewable resource. However, we need them now. And so we cannot make them fast enough to take care of our supplies that we need now. So they're considered non-renewable. All right, we're going to start with petroleum and natural gas and kind of talk about how these things are actually formed. And I mentioned already that they're from dead organisms that died over millions of years ago, but it gets a little more specific than that. First of all, we have to have what's called a source rock. This is a rock that has a lot of organic matter. Organic matter just means stuff that was once living. Okay, so it could have been plants, it could have been animals, it could have been, a bog that had lots of dead plants and animals in it. But that is over time turned into a rock, but it still has a lot of living or once living tissue in it. And then of course as rocks are formed, they go under a lot of heat and pressure, and that organic matter is turned into something called hydrocarbons, and hydrocarbons are our fuel, the fossil fuel itself. Now what happens to those hydrocarbons determines what type of fossil fuel it's going to end up being. We also need in our recipe here a reservoir rock. Basically, this is a rock that has little tiny holes or pores in it that allows the oil and gas to move once it's been formed from these hydrocarbons throughout the rock layers. And then finally, on top of that is another type of rock called a trap. Doesn't have pores in it, so it acts as a lid to keep the oil and gas from escaping. So we're going to go to a diagram here next that kind of gives you a better idea visually of what this means. But make sure you write this down in your little section on how petroleum and natural gas forms. Obviously you don't have to do this word for word, but kind of a general idea, an abbreviated version of what's going on here. So you can see in this picture that down at the very bottom, get rid of my words there. Okay, so down at the very bottom here, we've got magma, because we're very close to the bottom of the earth that provides that heat that I was talking about earlier. The source rock would be down here in this kind of orangey level right here. The porous rock, or the rock with the holes on top or in it, is on top of that orange layer. So you can see that the fossil fuels are able to move from this bottom source rock where they're made up to the top, the porous rock, so they start to migrate upward. And then finally on top, this brown layer is the non-porous rock, which creates the trap. And then of course if you're drilling for oil, you can see this little oil rig up here, you have to go down through the trap rock and get down into the porous rock where there's actually oil moving around. There we go. Okay, a little bit more information about natural gas. I'm just going to let you kind of skim through these and look at where it fits into your data table. I don't think I need to go through these piece by piece. You might want to pause the presentation here and take a minute to look at what the information actually is. So just briefly to guide you through it, and then you can pause it. This first one talks about where does the oil come from, and as well as the second one, so worldwide as well as the U.S. reserves. Third one is about how much of our energy we get from natural gas. Sorry, these two are where the gas comes from, not where the oil comes from. Again, transportation is a category you need to write about in your data table. So how do we move this natural gas around? And then just some interesting tidbits that might fit into miscellaneous. Most of the natural gas we use is methane, and it is the cleanest burning fossil fuel, so it releases the least pollutants. Again, you might want to pause this now to put it into your data table. Oh, I forgot one more. We have a little one down here at the bottom. How much do we have to supply us with? It says right down here at the bottom again. We have a 55-year supply if we keep producing at the same rates. In other words, if we don't discover any more natural gas and we are able to make it and use it at the same rate we are now, it'll last for about 55 more years. Alright, we can use natural gas for a lot of different things. Again, I think I'll just put these all up, and you can kind of, oops, went too far, and kind of add those into your table as needed. Again, why don't you just pause here so that you've got some time to write it down.